Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun geometry problem. So in this problem we have a circle that's inscribed in a quarter circle, and we know that the area of the inside circle is pi. We want to find the area of the blue region. So if you want to give this a shot, go ahead and pause this video. Otherwise, let's go ahead and jump straight into the solution. So let's go ahead and look at our little quarter circle here. And what I want to do is I want to break this up into a few different things. So first, let's look at the overall area of the green. So we know that area, I don't know why I'm not using green, so area green is equal to pi. And we also know that that's equal to pi times r squared, where r is the radius of our circle. So that's the radius right there. So what we can do there is we divide out that pi, we can see then that this radius squared is just going to equal 1, which tells us that my small radius is going to be equal to 1. So we know that that distance there is going to be 1. We also know that the distance coming straight down, so this is also just the radius, this is also 1, and so is this guy over here. So we have right angles, these distances are also 1. So looking at this circle, it's going to be useful. If we look at the overall figure, we can see that this side length over here is going to be the radius of our larger circle. But that's also going to be the distance going down from the diagonal down toward our corner. So it'd be nice if we could get that total distance. So in order to do that, we're going to look at this distance along the diagonal, and we're going to call this distance here the distance A. And I'll switch colors here because that's not showing up great. We'll make that a black A. So we're looking at this distance A that's going along here. So to get that distance, we notice that this is a square down here because I'm just made it with a bunch of right angles, so this distance is also going to be 1. So if I look at this triangle, I can see that in this bottom triangle, I have 1 squared plus 1 squared is equal to a squared, using the Pythagorean theorem, which tells me that a squared is equal to 2, which tells me that that a is equal to the square root of 2. So the side length a is equal to the square root of 2. What does that tell me? Well, that tells me now that my distance r is going to be equal to my small radius, which is 1, plus that distance, which is the square root of 2. So I've just described this longer side length right here, which is the same as my radius over on the other side. Okay, so now what we can do is we can solve for the larger of the two areas. So let's get the area of the total. So this is going to be the total area of the quarter circle. And that area is going to be given by pi r squared, which would give us the total area of a whole circle, divided by 4. So we're going to get pi over 4 times 1 plus square root of 2 squared, which is going to be pi over 4 times 1 plus 2 root 2 plus 2, which will just end up being pi times 2 root 2 plus 3 divided by 4. Okay, so now we know the area of the total region, and we're almost done. So we know that the area of the blue, so A blue, is going to be equal to that area total minus the area of the green region. So all we need to do now is put these all together. So this is going to be equal to pi times 2 root 2 plus 3 divided by 4 minus pi. And now we can factor out, so we're going to get that A blue is going to be equal to pi times 2 root 2 plus 3 over 4 minus 1, which is then just going to be equal to pi times 3/4 minus 1 is negative 1/4. So we're going to get 2 root 2 minus 1 divided by 4. And this is going to be our final answer for the area of the blue region. Hope you enjoyed working through this problem with me. Hopefully you were able to get it on your own. If not, a little bit of practice always gets us where we need to go. If you have your own video idea, please submit it. If you enjoyed this video, like and subscribe. And as you're working on problems, think once, think twice, and if you ever get stuck, think thrice.